Zombie apocalypse.
Hello, my dear viewers and learners. So, I'm here now to discuss from the course of structural steel design. No, let me present you the principle of collapse mechanism. So, I will try to discuss under this video lecture the necessity of knowing this and ano kaya yung importance nito sa ating structural steel design practices. So, let's get ready to be neurorized. Okay, first things first, let us try to validate this. So what makes us use this principle as for us to have the necessity to validate the information that we're going to have today in accordance to our design logics of steel, no? Which is as appreciated by our current code, which is NECP 2015, no? Now, let's take a look on NECP 2015 first printing, section code 502.3. It was mentioned here the design basis. Design shall be made according to the provisions for load and resistance factor design, which is katumbas ito sa concrete design ng chapter 4, which is USD as we know it, the ultimate stress design. Tinawag lang dito sa steel design na load and resistance factor design, although they are of the same concept, but to differentiate the differences between concrete and steel design. So, pinaghiwalay lang ng pangalan, but they are of the same concept. So, we are to factor the loads, that's the meaning, and I will try to discuss this in a separate video lecture, and also to the provisions for allowable strength design. So, bakit may pangailangan si code natin? I will try to expound this in our future video lectures, but as a bird's eye view, kasi deflection is very important, no? Lalo na sa structural steel. So, yun ang isa sa mga tinitingnan niya that unlike concrete design, deflection is already controlled because of some factors that we are using and some limitations. Sa steel kasi, we need to understand the way the behavior of the steel under load of how will it deflect, and kakaiba ito no kumpara sa concrete design. That's why both of these will be used. Now, do not be misled that this ASD and LRFD pertains to the new one. Okay, bakit may new? May old ba? Yes. There's what we call ASD old, no? Old ASD and old LRFD. Yes, you heard me right. Kasi itong dalawang ito, at ito yung nasa NECP 2010 pa natin, rather 2000. Okay, 2001 or 2000. Oh, let me write 2001. Why? Before kasi ang acceptance ng ASD is different from the ASD as we know it right now in our local code, in our current local code, which is 2015. Although in NECP 2010, no, we are going to discuss NECP 2015, no? Doon tayo sa first printing. And under 2010, it will be the same code almost, but there are some differences to the updates. So, which is we do have now the 2015. And clearly stated in 502.3.1 in the required strength, no? Chapter 5 ito ng ating NECP. The required strength of structure members and connections shall be determined. Okay, this first paragraph just only declares that connection is very important in designing. So, what does this phrase all about? Usually kasi whenever we design structural steel, beam, column, web members, you know what, whenever we design steel, structural steel, it is very important to make sure that it was taken care of yung ating connections. So because poor connections, even though your beam and column is well designed, then that would impose problem. Because a poor connection means an automatic failure to the whole structure since it connects the beam and the column. I think you will agree with me na hindi naman pwede lumutang yung beam natin at hindi naman pwede mag-stand alone lang yung column natin na without supporting other structural members. Now, here is the real thing. In the second paragraph, designed by elastic, take of that term, inelastic or plastic analysis is permitted. So therefore, the entirety of our NECP 2015 Chapter 5, which is steel design, is incorporating these concepts, elastic, inelastic, and plastic analysis. Whereas elastic is already known by us, of what you call the elastic theory, or the things that you have learned in your theory of structure. So let me call it as TOS. Inelastic, somewhat like the boundary that can be also perceived by TOS, but some additional provisions may be applied. And there's another term to look at, the plastic analysis. So this will be the main highlight of my discussion for this particular video lecture as the principle of collapse mechanism, or we can call it as a plastic analysis. So there's a need for us to learn first how does plastic analysis goes, because the design of beam, column, and might as well consider the connection, like also the tension members, are dealing with such conceptualization. Since for example, let me give you this another bird's eye view. In the principle of tension members, there's what we call the tearing or the perforation of the elements, or it can be a product of the block shear. So one of my video lecture will discuss that. And in such situation is there's shear lag factor U. Then those things should be accommodating the principle where plastic analysis will takes place. So in the portion where plastic analysis are observed. So it's very important that this is the first thing to be learned by the viewers or the learners who wants to understand who wants to understand the structural steel design methodology, and we can say the technology of design and analysis. Now let's move on to the next content of my discussion. So I'm only emphasizing the importance of knowing the plastic analysis principle, or also known as the collapse mechanism. Or sometimes it can be termed as, kasi many authors nagbabanggit ng collapse load, yan. So same na sila. You can call it collapse load, yan. Collapse mechanism or plastic analysis or etc. It's dependent, no? Doon sa bumabasa at nag-interpret. But if there's a term plastic and collapse, therefore we are talking about the same thing. So here is now the collapse mechanism. So the definition of such is if a body is subjected to any loading, it will offer resistance. Okay, before I continue, don't forget that when a beam is being loaded, whatever the type of, let's say represented by concentrated load P, it will be most likely deflect like this. And then if you put a larger value P, let's say as you increase the load P, okay, for example, let's take a closer look like this, no? Increase the load P gradually, then of course, the deflection will be gradually increasing. In concrete, in the logic of concrete, as you increase the load, then crack may happen in the tension side, and creep or most likely will happen in the compression side. And then finally failure. But in the steel, there will be such time that if you increase and increase the load, then the final output will be larger than the load, no? Na in-apply mo na una. Let's say that's the load P. Let me erase this. Na kasing laki tuloy ng load, okay? So, just like this, yan. So, until such time, that particular larger load, sabi ko sa inyo kanina, it will deflect like this, paunti-unti lumalaki, finally, bigla siyang gaganito, yan, 2 to P like this. So, this is the, isa sa mga magagandang property ng steel. Kumbaga, we are going to take a look that it doesn't offer that it looks like this way of deflection is already a failure. In the technology of steel design, as long as it performs, then it should be designed. Usually, steel experiences perforation, steel experiences dents o yung pagkatupi, but it doesn't offer that the steel already fails. Di katulad ng concrete walang dents sa tinatawag kasi pag nagka-crack yan, there's what you call the acceptable crack width, that is hairline width. But here, there's no such as hairline width, as long as the steel performs, then it should be designed, no? Yan yung definition nung sinasabi nung collapse mechanism, no, in the shortest possible way that I can explain. And the N and the N plus 1 represents the hinging effect. I'll discuss later how does hinging effect takes place in a structural steel member. Okay? So, I think one of the important statement here is if the load at which the body stops offering resistance to the external load, meaning as you apply the load, is called the collapse load. Ito yung collapse load, kumbaga. Kasi after this one, that will be automatic failure. Maghihiwalay na yung member. Mapuputol na. Yeah, until such time na in-apply with respect to time. And also, to follow the statement, a structural system will become a mechanism only when a sufficient number of plastic hinges are formed. Kasi you notice that in this region, the support, and to the area where the load is being applied, assuming that it is a concentrated load that is single. So there is some like hinging or a rotation that takes place, no, with respect to the area. Parang if I were to draw in a separate illustration, no, after the hinging effect are being applied or takes place already, so nagkakaroon ka na para slope dito, no. So you will notice this slope on the left, slope on the right, and slope somewhere in the middle where the loads are being applied. So that is the definition of the structural N, and then you have to take N plus 1 for the plastic hinges. Later, I will discuss there are two types of hinges that takes place on the system. Maybe on the part of the beam, maybe on the part of the frame. And the plastic hinges will form on the following locations. So, there's the term plastic hinges, okay? So, plastic hinges, ito yung definition kung saan talagang walang hinge, pero dahil natutupi meron. So, therefore, in this illustration that we're going to draw, if you are to achieve the, let's say, plastic deformation through deflection, so therefore, ang plastic hinge dito ay yung nagtupi dito. Ayan. That will create the plastic moment. Let's call it M sub P. And here is the plastic hinge. Let's say theta sub P. Okay? And of course, in the support side, which is a hinge and a roller, so may slope din of course, but that will be called a real hinge. Okay? Later, I'm going to emphasize this, but for the meantime, this is what we call the real hinge. Okay? Real hinge, or sa Tagalog, makatotoo ng bisagra, if that's a literal term. So, also this one. But here for the theta P is the portion where we call it the plastic hinge, where there's not really a hinge, but for the purpose of perforation or dents, then there's what you call fictitious hinge, the other way around, or the technical term applies plastic hinges. Okay? Yan. Ito po yung mga considerations. Sa nakikita yung plastic hinges, sa fixed support, at point of action of concentrated loads, the section at which the bending moment is maximum, and the section where the moment of inertia changes. Fixed support, of course, if you have what we call this, restraint beam, or we can also have some prop beams. So where's the point of the plastic hinges? On the point of fix. Yan yung mga nagde-develop ng plastic hinges. Now, point of action of the concentrated loads, as discussed here, ito po yun, yung theta sub P natin. Okay? And the section at which the bending moment is maximum, depende kasi sa load ito, pwedeng multiple loads, pwedeng uniformly distributed load, pwedeng continuous beam. So, that is the base cases, no? Yan, kung baga titignan natin, yung rotation final ng ating beam bending is, let's say, for example, sample lang po ito from the previous discussion, kung nandito yung nakitang plastic moment, so therefore, of course, automatic, andito yung, yung hinging effect. Yan. And the section where the moment of inertia changes. So, kasi may tinatawag na irregularities to the inertia, or what we call non-prismatic condition. Yung nagbabago yung inertia o yung nagbabago yung area. So, there's also another portion for that. So, these plastic hinges have limited rotation capacity that offers no rotation. So, yan yung, pero nagkaroon ng ikot kasi may lumaban na load. That's a plastic moment. Okay, the collapse load for the plastic analysis of structures can be determined from the following theorems. It can be static, kinematic, and uniqueness theorem. Now, let me discuss a little of what are those three. And it has a very important role in understanding collapse mechanism. Under static or lower bound theorem, it states that the load computed on the basis of an assumed equilibrium moment diagram in which the moment are nowhere greater than the plastic moment, is less than, or at the best equal to. So, meron siyang parang limitations of the boundary, and that will consider static. Okay? The static theorem was first suggested by Kiss and its proof was given by Bosder. Please correct me if I'm wrong in pronouncing their name, Greenberg and Horn. And while the kinematic or upper bound theorem, it says only that a load computed on the basis of an assumed mechanism para magkakaroon ka ng play basis kung saan nangyari yung plastic hinging will always be greater than or at the best equal to the correct collapse load. Ibig sabihin, yung property to capture load, if the collapse load, let's say P sub CP, P sub CP, okay, if the PU captured is greater than, then you're talking about kinematic. While PU may be less than or equal, so lagyan na natin muna na ano, doubt yung equal sign, then that should be the condition. Okay, to summarize it up. So that will be the achievement of the true ultimate load, where most likely, we should be go above the capacity pagdating sa ultimate loading if we're talking about collapse mechanism. But of course, don't forget that the capacity to resist load is different to the capacity that is the influence of the stress involved. So usually when we are designing, it is the stress that we are going to check with, no, in relation to the ultimate. So the upper and the lower bound theorems, which is the static and kinematic, can be combined to produce any uniqueness theorem. So usually yung mga element na we cannot identify if that is static or dynamic. Okay, usually mga sabihin na natin dito, example is a tower crane that looks like static, placed above the construction site, but due to the fact that there is an exposure to wind or potentially direct exposure to seismic activity, then it may be considered as it is moving dynamically with the force as an effect do sa ating mga environmental loads. Then it may be considered to to produce the uniqueness theorem by considering both static and kinematic, so that it would be the true correct collapse load. Another thing, usually pwede natin ito i-apply sa ano sa mga analysis ng mga scaffoldings, where whenever we erect the scaffoldings, it is highly exposed to high winds usually, no? Mas vulnerable sa malalakas na hangin yan. So it may produce the uniqueness theorem. Other than that, it can be isolated, static or kinematic. Depende yan kung ano yung condition of analogy. Usually, it may lead to performance-based design. Okay? Now, how does the process of plastic hinge formation goes? Assume that we have the system, a simply supported load with a concentrated load, let's say somewhere in the middle. We are aware, or in the middle I mean, we are aware that whenever we draw the shear diagram and the moment diagram, especially the moment diagram, so ito yung mangyari no, sa moment diagram natin. So it is the location where we apply the P sub U, no? In the stress, of course, if M is less than equal to My, these are the stress diagram. So yung M sub Y represents yield moment. Yan. Why yield moment is existing in the design? Kasi all materials has the potential to move, and movement means yielding. So especially steel design, structural steel design has the yield stress. So therefore, if there's a yield stress, there's always a yield moment. And yield moment is very important in analyzing and understanding the behavior of steel whenever it is applied as a beam, as a plate girder, as a column, as a beam column, and etc. etc. Okay? So if M is less than or equal to My, meaning there's no point in yielding condition, then it follows a straight line stress diagram, meaning this is under the influence of what we call allowable stress design. Okay? We have learned this during strength of materials, no? That if a stress follows hook slope axial deformation, then you're under allowable stress design. However, due to the development of the stress, so para anong nangyari? Ito yung deflection niya in color in red marking. So para yung deflection niya is somewhat like that, no? Parang elastic behavior. And then finally, as you increase the load more, so nagkakaroon ng distortion or semi inelastic, okay? Or should I say partially plastic. Ibig sabihin that the moment is in between the yield moment and the plastic moment that it can carry. So, usually, dahil ito nagkakaroon ng shifting of the stress value, ito'y bababa at ito'y tataas for what particular reason, it is because the behavior of the deflection that it suffers from the bending. So, if I were to draw this on the same beam, so lumalaki yung yung deflection, pero it follows somewhat like near bending. But kung titingnan natin yan in a more precise vision, kung sa color red or allowable sign is perfectly, let's say, parabolic, in partially plastic section, nagkakaroon siya ng konting straight line sa deflection na hindi na natin napapansin at parang pag ganyan. Medyo stiffer na siya. Pero it looks like a parabolic but not entirely parabolic. However, if you reach that, if the moment is now equivalent to plastic moment, you cannot go above the plastic moment because having a moment more than the plastic moment, I'll call it M sub UP, or in our sense, sometimes it can be called as M sub P. So therefore, failure will really happen under this case. Ibig sabihin, naputol na yung dalawang segment. So therefore, hanggang plastic moment lang. So therefore, what happens, marked in green color, ang stress diagram natin nagiging straight line. So ito yung tinatawag natin plastic analysis. Okay. Under this plastic analysis, okay, dito na pumapasok si load resistance and factor design. Okay? So, sa load resistance factor design, ang nangyayari naman dyan is, sa deflection is nagiging ganito na siya. Straight line na. Yan. Kung saan yung point na may malaki occurrence yung hinging, then that will be the point. Usually, sa concentrated, that I will discuss in the following video lectures of how do we consider hinging effect when it comes to different types of load, then that would be our next discussion. But for this time, let us appreciate how this material behaves under plastic analogy. So, yan po yung nangyayari under plastic or collapse mechanism. Or simply say, plastic analysis. So, sa plastic hinges, kasi ito yung nangyari. So, in this region, parang, literally, no, pag natutupi kasi yung material, I'll try to mark it in red para mas madali makita. So, kung titrace natin to, yan yung mark it red, ito yung hinging. Kasi pag isang material is nag-deflect, ayan, in such a way that it is better understand, no? Sa hinging effect, kasi, puputulin ko dito, ito yung point na nagkakaroon ng hinge, yan. Okay, ito yung may kinalaman sa theta sub P, let's say, or plastic hinges. So, dito, meron ditong imaginary ball point na kung saan nagkakaroon ng parang tinatawag nating hinging. Yan yung pagkatupi in other term. Okay? So, yung pinapakita ng region na I'll try to shade it in red. Ayan. No? Yan. Kinukulayan ko ng pula so that you would better view, or we can try violet para yan makita. Pinagsama ko ng violet at red para a darker color may exist here. So yan yung parang portion na natutupi where plastic hinges takes place. Okay? So it can happen to a beam and frame like this. Okay? So yan yung parang mga sample illustration kung paano nagkakaroon ng collapse condition. Okay? So, pag sa beam ganito, pag concentrated, but there are so many kinds or different ways to produce collapse condition. Pag sa column or sa leg, paano pag sa entire frame in-apply or sa joint ng frame, at saka what if combination sa frame, isa sa joint, isa sa mga element of the structural members like beam and column. Also, paano pag continuous beam, nagkakaroon ng itong involvement. That I will try to discuss piece by piece so that you would better understand how do we clearly identify what's a portion of plastic hinge or real hinge. So, dalawa po term natin dyan. Una-una po, hinanap natin dyan yung plastic hinge at saka real hinge, and then followed by a calculation. Ngayon, after knowing those, so how do we calculate? What is the principle behind of calculation? Then the existence of the visual work method will be applied. Okay? So by this statement, you are to apply visual work method. Then if you are aware of visual work method, that is already discussed from theory of structures, that energy in is equal to energy out. Ang dami na in-applyan ng itong principle, especially virtual work method as this, the topic suggests. So dito nang galing integrable equation for the beam, for the slope, and for the final deflection. Now we are to use the small angle theory that I'll try to explain later that, or today, i-explain na natin that if you recall, if the angle is too very small, then tangent theta over is equal to y over x, then we can say that theta in radian, because the latter is that the previous is the theta in degrees equals y over x. So somewhat like equal. So there's what you call the external work done equals internal work absorbed, or energy is equal to energy out. Now, let's take a closer look. Let's say, for example, this beam deflect like this and a load like that. Of course, if you apply force P under collapse mechanism, there will be an equation, there will be a production of deflection under collapse. Let's say plastic deflection, delta sub P. Okay? Delta sub P, I try to write this in a clear way. So, in violet color, delta sub P, yan. So, therefore, it is clearly stated that as you apply the load P, the production is obviously the side of deflection in terms of plastic deflection. That's why the external work done is P delta. So, where's the internal work absorbed? So, whenever we produce deflection under plastic condition, there is always an equivalent, no? A plastic moment in the system that happens, let's say M sub P, with respect to the angle of rotation under plastic that we don't know if these two will participate, let's say L, let's say R, so okay, theta sub R, theta sub L, depende, no? Kasi meron kang real hinge at saka plastic hinge, but in the other way around, that is the MP times the theta, where the theta is equal to the sum of all loads. I mean the sum, okay, the sum of all theta under plastic condition. You have to take all the moment. Now here is the rule. Now for real hinge, no, and plastic hinge, dito ko, RH represents real hinge and PH represents plastic hinge and the plastic hinge value. So you have to take a zero value if that is real hinge, and plastic hinge should be a value of theta inside the equation. So therefore, if you encounter true hinge, then consider it as zero slope. So this may consider like this, no? Tulad nito, we are aware that this is true hinges because it is represented by a roller and a hinge. Then, for plastic hinging, then it should be treat as real hinge. Yan. So sabihin natin RH, no, from this practice, and then until we calculate future problems like that. And then from the portion where the load is applied, assuming this is concentrated, then it will produce a deflection under plastic. Then there would be another plastic condition for slope. They say we call it theta. Now for some discrepancy, we call this theta sub L. We call this theta sub R, and we call this just simply sigma theta. Okay? So later we'll try to analyze by using simple mathematics on how to calculate that. But the thing is that below the load is an automatic non-true hinge. Hindi siya totoong hinge, ano? Kaya that's why we call it plastic hinge or PH. Okay, we know that the real hinge is set to 0 for a simply supported span. Now just like this, on the restrained beam, then theta, let's say this is theta L, and then this is theta R, no? On the left and on the right. So 2 theta is just a product of those theta because we need to understand the mathematical value for this, and then this delta P below the low W. Then we can say that this portion of the left, let's say at A, no? Sabi natin A para it follows the letters upon the given condition. Sige, pangalan natin A, theta sub A, this is theta B, and 2 theta. Sabi natin ito yung sigma theta. Okay? So, this portion on point A is plastic hinge. This point B is also plastic hinge. And, of course, the point of collapse is also plastic hinge. So, there are no real hinge because you can notice that A and B are fixed support. And fixed support, under my discussion earlier, it offers plastic hinging pH. Okay? Because we are aware that the slope in the actual elastic theory is the slope is 0. So therefore, it counters the load. Para makatupi siya ng ganito, okay, para makapagpatupi siya ng ganyan, it exerts plastic moment within the system. So there is a plastic moment happening inside the system. So that's the idea. That's why theta sub A and theta sub B are not 0, because initially it is true 0. Then to make the slope to exist, or we can say that to make the slope on the fixed support not to become 0, then there is an applied plastic moment now to make it move. Okay, that's the idea. And the following problem that we're going to solve, no, separately, to showcase how does a collapse mechanism is being done for example of for a sample of determinate, indeterminate, and of course including the continuous beam. Okay, so I hope that you have learned today something new regarding structural steel design, and let us continue learning by understanding how does a collapse mechanism are being calculated. So by this, let us don't forget our practice as a ano ko baga, ano, kultura na natin sa ating video lecturing. Again, you have been neurorized, and see you in our next video lecture. So coming up next is the discussion of how do we calculate the collapse mechanism on different types of supports, of beams with different types of support.